Hello everyone, my name is Jivita BS and I'm delighted to present my MSc internship project titled Fraud Proof Finance Harnessing Cloud Technology and Secure Finance Infrastructure, which was conducted under the supervision of Dr. Kamil Mahajan. This project focuses on one of the major issue in the financial world, that is fraudulent transaction. We're going to discuss how we can leverage cloud computing and the machine learning to build a end-to-end fraud detection pipeline. In today's financial institution, the major problem is the fraudulent transaction, which has been growing day to day. So, billions of dollars are lost annually due to the fraud, and there is a reputational damage on the organization. In the traditional fraud detection system, which are followed by the rule based, they only flag the transaction happening above certain amount or happening in the unusual times. While these rules work sometimes, but they also result in I false positive like which also blocks the legitimate customers, which allows the customer to lose a trust on the organization. To to have a solution for this, we are building a cloud-based AWS fraud detection pipeline end to end using ML models. My central research question here was like how to enhance a fraud detection system using AWS technology for the real-time transaction data, which is also as secure and scalable. To answer for this, I had a four objectives. So the first one is the exploring the existing fraud detection technologies and their weaknesses, and to develop and design a AWS based cloud fraud detection pipeline, and to deploy both real time data and the batch based data and test both the scenarios, and to also evaluate accuracy, latency, and the scalability, and also mainly to check the cost efficiency of the usage and to meet the standard regulatory compliance. So from the literature review and all the researching all the industrial paper, I found that the traditional rule-based system has a like high false positive rate where it blocks the legitimate customers, and it has less scalability where it won't be able to add the sudden spike in the traffic during any events or any holidays time. And also, I also found that there is a research on the integration of both ML model and a cloud, but there are few papers which suggest there is an implementation also of about legal work and the compliance on the existing system. So this gave me chance to improve accuracy also, but also to build a design where the fraud detection system is compliant, secure, scalable, and able to handle the real-time transaction data. So this is a proposed architecture. We have a AWS WAF where it has a first layer of defense for AWS environment. Next, we have API gateway, which acts as a gateway for the secure gateway for the all the transaction data entering to the external application. Next, we have Lambda. Lambda is here as a two function to ingest and to predict. Ingest in the ingestion, it takes the data from the API gateway and it gives the data to the where it pre-processes the data and give to the Kinesis data stream. Here, the Kinesis data stream is to stream all the real-time processes. It streams it and buffer it, and it passes to the next function, that is a prediction function. In the prediction function, it fetches the data from the Kinesis. It formats the data which is required by the SageMaker, and it is fed to the SageMaker. Here, the SageMaker is the ML model, built-in ML model, which is present in AWS, which uses a random classifier to classify the transaction, whether it is a legitimate or fraud. Once the prediction is made, all the data are sent to S3 bucket for the batch training for the future usage. So all this activity is being monitored by the CloudWatch and the CloudTrail for to have a better tracking and for the auditing purpose, which is very important for the compliance. So I have used AWS service setup region to set up on the US region, which is Ireland region as well. And I have enabled IAM policy on all the services to have to ensure there is a restrict access to ensure there is a no unauthorized access on the services. So to test here, like I have created two scenarios. One is legitimate transaction and the fraudulent transaction. In the legitimate transaction, I have created a normal spending patterns and low velocity, and it has a consistent location and the consistent amount. But in the fraudulent transaction, I have an unusual pattern of the transaction where the transaction is made by a suspicious IP or the abnormal what abnormal amount of money is transacted, and with with unknown geolocation, like if the location is done, if the transaction is done in India, after a few minutes it's done in USA. So all these patterns I have created. So to this was always created to mainly to identify, detect the all the fraudulent patterns in the real time, and to reduce a false positive. So along with this, like I wanted to calibrate the accuracy, precision, recall of all the patterns which we have created, and to create a and to know the latency, where like the time taken by the SageMaker to decide whether the transaction is fraud or legit. And I also wanted to check the through output, where like for per second how many transaction can the system handle. So also wanted to check how the like how we can reduce a false positive versus negative. And the main thing was for us to like to focus on the cost efficiency and the compliance, like we made sure that like the logs are encrypted and follow all the regulatory compliance required by the GDPR and the PCI. So the system performed very well, like actually as expected, like where we got the 300 to 600 millisecond of the average latency. And for the accuracy, we got almost like up to 99% for the medium load. And for the scalability, we saw that like the system could handle at like 10,000 transaction requests within a span of 5 minutes, which was very good. And for the for high precision, like to have a better precision, like we fine tune the threshold. So the default, like usually they use like 0.05, but here I have used like I fine tune the threshold like to 0.07 to get the accurate prediction. So for the additional, like as I told, like to the as a defense layer, I've added a WAF to block all the malicious requests which we injected. So this is a low, medium, and high I've created. So here I've given three workloads, as I mentioned earlier: low, medium, high. So in the low, I have fed like 100 transaction within 1 minute. In the medium, I have sent like 1,000 transaction within a minute, and 10,000. And for the high, I have sent 10,000 in the fraction of 5 minutes. So this is the confusion matrix for all the three scenarios. And this is a decision for the low. This is a legitimate and the fraudulent decision made by the SageMaker. This is a latency and the ROC curve. So all the system, like we could successfully test the fraud detection pipeline. We had few limitation where like we used only synthetic dataset that is a dataset we created, but we couldn't use the real-time word dataset. So we couldn't, we may not have tested the actual like very difficult fraudulent patterns. Also, we tested on AWS cloud only. We couldn't test on Azure and Google Cloud due to the time constraint. So there was a latency of only 1 second in the highest workload. And we also observed that the keeping the SageMaker up for long time costed a few money, and the rest all the other services cost was less. And we also saw, due to the time constraint, we couldn't test on the adversarial attack or the bot attacks. So overall, we developed a secure and real-time fraud detections pipeline where we could identify the fraud and legitimate traffic. We also saw that like it is a scalable and it is accurate. Like the most for all the three workloads, the accuracy was about 95%. And we also made sure we are compliant towards the standard regulatories. So in the end, like I would like to say, like this solution is very feasible for the financial institution to adopt, because this is a it is scalable, and it has a cost efficiency as well, and it is more easy to handle the real time data instead of the traditional based detection system. Moving on, we'll go to the demo. So we have created in the EU region. So we have created a web ACL fraud API WAF, which is associated with the API. So all the requests will pass through the web through the WAF. We check the malicious request and it is fed to the fraud API gateway. So we have enabled the rules, AWS managed rule. So based on this rule, the request will be blocked by the WAF. So this act as an entry point. Here I've created both option and post methods. In the post method, you can see the integration request is fed to the Lambda. So all the incoming requests are gone into the Lambda, that is in trans ingest function. So what does it do? Like this pre-process the data and it gives us to the Kinesis. So I have found here. So I've enabled the value as the trans stream. This is the name of the Kinesis data stream. So the on all the services CloudWatch is enabled for the monitoring purpose. Here I've used one shard for the testing purpose only, and the KMS keys are enabled on the stream so that all the transaction logs are encrypted. So once the data is buffered in the Kinesis, it is fed to the Lambda transaction prediction function Lambda. So this formats the data and it is given to the SageMaker. This is our SageMaker name. So profile. I'll be launching the studio now. So we are using SageMaker Studio, where we'll be using a Jupyter notebook for executing all the code. So this is a workspace which I've created. So this is a data set which were created, and all the data set are here for test and for train data set. These are stored in S3 bucket. So once the data set is stored in S3 bucket, we started training the data and prepared it for the training. So this like we prepared saying that like we need all these features. So once the data is prepared for the training, we did the batch training. The training was completed. So once the training was completed, we made sure like whatever the features we are using in the raw data set, the same feature is fed to the Lambda as well. Yeah. So then I requested one sample data to check for the prediction. Then I got the prediction rate. So once that is done, I've installed all the libraries for the visualization and for the to get the graphs and everything. So this is done. So here I was checking the just sample scenarios, low, medium, and high. Along with that, like I wanted to check if it blocks the malicious request. Like I had injected the SQL injection here, so it like you could hear successfully it was blocked by the WAF. Yeah. Also after that, I wanted to check if the log is really sent to the S3 bucket. So the real time logs are stored in S3 bucket. And then like I gave the three scenarios, low, medium, and high. The transaction was fed to the APIs. So we got to test it. So we could see here that like all the 100, whatever the data we sent, like 100,000 and 10,000, all were loaded into the system. So once that is done, we started testing it. We gave the SageMaker to predict for the prediction. So we got the prediction like which is like in that like 47 were legitimate and 24 were fraud. We got the precision for low is 95 and for the medium is 97 and for the high it is 97. Once that is done, like I formatted the data graph for all the three scenarios. Yeah. So later, we created a confusion matrix, ROC graph, and uh, a precision versus recall graph we created. So we have a final graph for here for each low, each workload, low, medium. This is a confusion matrix for the low. Yeah. So this is the final output where you could see the detail, like the evaluation matrix here, accuracy, precision, and recall, FR and TP for each of the workload. So due to the time constraint, we couldn't work on the FP and FPN like more. As you can see here, like there are two false positive and false negative reported for the legit and fraud transaction. Later on, like we did end-to-end testing, like where I injected all the malicious traffic. So I wanted to check if the WAF is gonna really block it. So as you can see, all the traffics were blocked. Yeah, all the traffics were blocked. So all these logs were being monitored in the CloudWatch, where we have created all the groups for each services. Yeah, here you can see the logs are being blocked. Yeah. Mhm. Yeah, you can see the logs. All the logs are being monitored. Yeah. So overall, we could say that like we successfully tested, and we could see that the system which created had a high accuracy, and it is also scalable, where we tested all the three different scenarios.